The periodic table is considered a major thing that we use in chemistry. It contains a bunch of symbols and elements and numbers, but we don't understand some of them. Well, that's what I'll be talking about today. In the old days, we didn't have fancy technology. Duh. We instead just identified elements, or so-called elements, by their appearance. So we had fire, earth, water, sky, and so on. As time passed, we were able to get better tools so we could gather better resources. So eventually we were able to get bronze, iron, and copper, and things like that. In the 1600s, or sometime around that, we are able to create the microscope. The microscope then helps us to see a lot of things. So if we get a sample of our blood, or if we get something out of pond water and we pop it in there and we look at it, we see things in there. Cells, living things, and a bunch of other ginormous molecules. So, due to the creation of the microscope and also us being able to see all those things within the microscope, scientists and people overall started theorizing a bunch of stuff and started writing their own papers, theorizing the ideas of atoms. They were kind of silly and not exactly what we see in the modern day, but hey, you can't blame them. They couldn't see anything. Eventually, in the late 1800s, a guy named Dmitri Mendeleev published a periodic table, which our modern periodic table is mainly based off of. His periodic table listed a lot of elements that we know today, probably about 70 of them. So, as more time passes on, we finally reach to the 1900s. We are able to get even more legit technology, such as mega drills and a bunch of other fancy microscopes, and we're able to delve further eventually, where we finally get a good picture and view of the atom. Which now, finally, oh thank God, leads us up to the modern day. Now, the periodic table is consisted of a bunch of squares with letters in them, numbers on them, and more things. Every single horizontal row is called a period, and every single vertical column is considered a group. Those two thingies on the bottom, however, are kind of special. They actually go between an area. Some elements are particularly different than other elements. We have the metals on the left side. We have the metalloids in the rightish middle. They are half metal, half non-metal. And on the right, we have the non-metals. This mainly separates these elements into the main groups, such as which ones are solids, which ones are liquids, and which ones are gases, mostly. That is, if you're at room temperature. Because the periodic table identifies elements, let's take carbon for an example. It has an atomic number of 6 protons in the nucleus. It has an atomic weight of 12.011. That basically means that the average mass of all the carbon atoms on this Earth is 12.011. Protons weigh 1, neutrons weigh 1, electrons are nearly weightless, so unfortunately they don't count. Poor electrons. It has a symbol of C, well that makes enough sense. C stands for carbon, and is in period 2, group 4A. We'll try to understand those later on. The only reason why the periodic table is so important is because it's like a fast guide that helps us do almost everything in chemistry a bit faster. We use these symbols to make up compounds instead of having to write them down. They are more efficient, and also we're able to represent chemical reactions and things like that easier. As along with finding the weights of compounds and estimating how much of one isotope is within our world, which we'll kind of learn a bit later. So, the next time when you see an explosion, you'll be able to know what type of elements went in and what type of elements went out, basically understanding how it works. It might not seem that great, or you might not want to know, but hey, it might seem cooler for you. So, I guess this wraps up another episode. I'll pop the next link sooner or later. And, well, I thank you for watching. If you have any ideas for videos, please leave them in the comments. And, well, I guess it's enough said, so peace.